Awesome, yeah. Hi, everyone. I think I've met some of you, so good to see you. So I'm a pedologist, or right now I'm a research soil scientist for the Soil Health Institute, but today I'm here in my own capacity, so not speaking on behalf of the place where I work, but I basically just finished my PhD from the University of Vermont and moved down to North Carolina, where I'm working with soils and agricultural context, but before that, I was working in forest soils and some urban soils, so just lots of good soils. And yeah, today I just wanted to talk to you about some things that have been on my mind recently, and in my work, kind of broadly connecting different soil environments. And I'd love to hear more about your perspective, because I think the intersections of what you do and what I do are really cool. So I wanted to start out with just the most basic question ever: what is soil? Can anyone give me a definition of that? I'm sure everyone can, but yeah. Dirt that nurtures plants is definitely one definition. Yeah, that's a good definition.
Material?
That's an interesting material definition. So you mentioned broken down leaves. I would say actually most of it, 45% of it is broken down rocks. And so that's going to be a ton of mineral matter, think quartz, feldspars, micas, and lots of other minerals. Only 5% or so is going to be broken down organisms, so living and dead things. And then the remaining 50%, anyone have an idea with that? Air and water, yeah, in varying proportions. So that's the kind of the material definition, but there's also kind of a soil functional definition, which would get at, a medium for plants is an important part of that. It also stores a lot of water and nutrients that are released over time. And it has some interesting functions like filtering pollutants, breaking down. It can break down pharmaceuticals and petroleum products, and also houses an astounding amount of biodiversity. So I think there was a recent paper that showed 60% of the world's biodiversity is actually in the soil. And soils are not the same place to place, as you may know already. So they are a combination of these different soil forming factors. One of them is parent material or geology. We've got climate, which would represent temperature and precipitation, organisms, relief or topography, and then time, which is kind of the reactor that all these other things pass through. And all of these combine to produce a single soil. You can think of it as a species, but this is our state soil. The Cecil series, soil series, would be that that smallest kind of unit at which we would consider a soil. And in soil jargon, it's a fine kaolinitic, thermic, typic canhaploidalt. So super accessible language in my field. We really want to bring people in. But you can break it down according to those soil forming factors. So kaolinitic just means it has a lot of kaolinite, which is a type of clay mineral, which gets at that parent material. Thermic speaks to us about the climate. We're in a pretty warm climate here. And then the rest of it, that ult on the end, tells us that it's a very old soil. So it took hundreds of thousands of years to make.
When you say state soil, you mean state of North Carolina?
Oh yeah, sorry. Every state has its own soil, which is just a fun little fact. But I'm leaving out another soil forming factor. So there's been debate over this because we are an organism, but humans exert a pretty tremendous influence on soils. We are a huge engineer of soils, and we can influence all these other factors. So we can truncate soil profiles by developing. We can even turn them on their head. And all of this, of course, affects soil properties. I want to talk to you about organic matter today, so we should define that as well. Anyone got an organic matter definition?
That was once living?
It actually includes living and dead material. So Yeah, I guess like we're all organic matter in some capacity. At least when I'm in a soil pit, I might count as organic matter. But this image is of a soil clod where you can actually see this represented pretty well. So this is a soil clod I took from Vermont forest in the Green Mountains, and the scale bar is there, and basically I glued this clod and sliced it super thin and then looked at it under a microscope. But you can see some of the dead plant tissue has retained the structure, but is starting to go through that decomposition process. Over on the right, though, there's material that is the same color, that like dark black color, which would say organic matter to me, but it's a lot more like amorphous. It's lost a lot of that structure. And organic matter has a huge range in composition depending on the stage of where it's at in terms of being broken down. And what's cool is that this process sequesters carbon in the soil. And so we can think of organic matter from, again, a compositional viewpoint. So like it's got lots of carbon, nitrogen, other things in it that are characteristic of organisms. But it's also got a lot of like important functions in the soil. And it plays an outsized role chemically in the soil. So yeah, we're all future humus. Humus is that word for very broken down organic matter.
That's gotta be a shirt.
I don't think it is. I want to make it a shirt. My partner said everyone would think it said hummus, but all right. So let's get at some of the functions of organic matter. This is a farm demo I was recently at. So we've got two soil clods. They're from the same soil type, so both the same soil species, but they're managed super differently. So in this clod, we had no-till practices and lots of cover crops. And what that means is anytime there's not a cash crop being grown, there's something else that's in the soil. So do you notice any differences between these two soil clods? Mm-hmm. Yeah, what do you see?
More porous. Yeah, what's more porous? It's more compact and fine.
Yeah, pores and texture, exactly. Yeah, so there's maybe a burrow in there. There's lots of little cracks, and there's these weird little circles, which are made by earthworms. And there's also some roots coming out. And I think if you look even closer, there's maybe even some dried out hyphae or fungal hyphae. Whereas this one is totally just smooth, almost smooth, and lacks a lot of that structure. And that has a huge impact on the ability of the soil to absorb water and drain water. So those are those two soils side by side, and we're putting water into them. You can notice this one is allowing all of that water to filter through, whereas the one next to it, it's just sitting on top. And you can imagine this has implications for aeration and lots of things. The roots are going to be having a different time in that soil on the right. So organic matter has this influence on the soil structure. It has additional functions as well that, based on that structure, that have to do with some of the living things. So here, the void space in this clod is given in white, so a little counterintuitive. But do you notice anything about about the shape of the pores in this clod, or the nature of them? Yeah, there's different sizes going on, and that's really important for soil fauna. So as I mentioned, 60% of the world's biodiversity is being in the soil. We've got a ton of trophic levels, so a lot of different functional groups of soil organisms. We've got everything from mites, maybe earthworms, down to nematodes and bacteria, and all of this stuff needs different habitats. And when we build soil structure, we're building all of those habitats. So this is probably hard to read, but it's a graph with body length of these different groups, and basically they thrive in different sizes of pores. So these pores hold on to water films, which are able to support these different types of organisms. I guess there's some other organic matter functions that I'm leaving out here, like ability to absorb nutrients such as calcium and potassium, and then an ability to buffer acidity as well that are really important. But organic matter is shaped by all of these soil-forming factors that I mentioned earlier. So, for example, it takes a while for organic matter to reach equilibrium. You can dump a bunch of it into it, but it's going to be processed relatively quickly, especially in a climate like here. Climate is going to affect the production, but then decomposition as well. So, for example, in Vermont, we can get organic matter that is super high in the soil, maybe like, up to 5-10%. But in North Carolina, we're kind of limited to 2%. Vegetation has huge differences, even individual tree species. And then parent material has an effect. So our clayier soils are going to naturally be able to have higher organic matter. And part of that is due to the protective capacity of clay. So clay is negatively charged and so can bind organic matter and also protect it in little pores. It has less aeration as well. And then finally, drainage is gonna have an effect with, if you have longer periods of saturation, you're gonna be able to store more organic matter.
What does that first bullet mean?
Yeah.
The time.
Oh yeah. So so organic matter is added to the soil, but then it breaks down through the work of microorganisms, right? So if you dump a bunch of organic matter in the soil and keep dumping it, you're going to end up processing a lot of that, but like a lower amount is going to be left in the soil than you would have after kind of equilibration over hundreds of years. So part of that is because we haven't had the time to build up these like really recalcitrant carbon compounds. So we're not able to build up the full stock of organic matter on the outset because it's not it's not reached equilibrium yet. And decomposition is way slowed by anaerobic environments. Right. So that's a factor. But yeah, there's a lot of variables, I guess, because mineralogy is also important and protection. But yeah, I would say aeration stimulates decomposition. Yeah, so this is good. Maybe I should come back and give a part 2 on this. No, that would be great. Yeah, please, yeah. Yeah.
And then the macro deconstruction, like breaking into small bits, is important, but isn't necessarily decomposition, strictly speaking?
That's a great question. Yeah, so I'm not an expert by any means on that piece of it, but I think it's often very linked. So like termites have their own kind of microbiome that I think is often very specialized to them. And that's, certainly they're mechanically breaking up, but I don't know if they're separable from the bacteria that do the actual work there. So it's interesting to think about because whereas, yeah, and then like worms, for instance, like they also have microbiomes that do a lot of that work. So yeah, that's an interesting.
So it's more like the system does it rather than trying to do the human thing where you're trying to isolate who is responsible.
Right? Yeah, I think so.
Mm-hmm. Takes a team.
So as I mentioned, North Carolina might have different organic matter storage capacity of the soil than, say, Nevada or Vermont. But organic matter also varies with depth in the profile. So I had to bring my prettiest soil profile from Vermont. I'm sorry those soils aren't here, but we also have very beautiful soils. And this is kind of how I found organic matter to vary in the profile. And what's interesting about this profile is that we've got a lot of fresh organic matter near the surface. So broken down leaves, varying to very broken down leaves and litter and animals. But then we've got this like bleached gray horizon, which has been leached with acidic, organic acid-rich waters, and that has actually brought some of the mineral matter and humus, or organic matter, down in the profile, which led it to be in that dark brown horizon. So basically, some of the weathering products are like sticking to that organic matter and bringing it into that darker layer. So that's kind of fun. All right, so how can we improve soil organic matter? This is a big question that is like on my mind a lot, because it would be huge for our planet if we were able to store more organic matter in our soils, from both a drought resilience, climate resilience perspective, to also a carbon sequestration perspective. One way is to imitate natural environments. So forests do a great job of storing soil organic matter. Obviously, you've got like woody biomass and leaves and all the organisms that depend on those ecosystems going into the soil, and lots of living roots there as well. However, it's not always practical to leave, like giant amounts of organic matter, especially in a yard, in like a suburban or urban environment. But what we can use is some of these principles of soil health or organic matter stewardship to get at a reasonable way to introduce organic matter. So these are principles of soil health that are mainly used in agriculture, but I'm interested in how they resonate in other contexts, because I think they're pretty applicable as like a homeowner myself. Like I use these, and I've started to get pretty protective of my organic matter in my yard, I guess. But one principle is armor. So you want to protect the soil from erosion, no bare soil. And this provides habitat and preserves moisture. Another principle is minimizing disturbance to the best way you can. Cultivating above ground diversity. So lots of different types of living roots can help build the rhizosphere, which provides a lot of organic matter through root exudates and other features. And then having continuous living roots in the soil. So this feeds the soil food web, which is largely concentrated in that rhizosphere, and it also stimulates aggregation. Of course, some plants are going to be like, I don't even care about any of this. Like, I spent the first few years of my life on a literal rock. Like, what do I care about healthy soil? But I think what these principles do is they help us figure out how to behave as that sixth soil forming factor. So how can we sort of steward the soil in some of these environments where we've had a huge effect on soils?
Would you define
Yeah.
rhizosphere real quick?
Oh, sorry. Yeah, the area near the roots, which is just a super active, biologically active zone. That's where a lot of the bacteria and other things like to hang out. Thank you. So yeah, and just a note on this, it's not prescriptive. So there's not one organic matter percentage that is right? Different soils are healthy for different ecosystems. You might have really high organic matter in a bog, but a bog is pretty acidic and saturated for long periods, and that might not be reasonable for another system. Okay, so I'm going to close out just with some sappy poetry here. No, but it's been suggested that the English words human and humus, or organic matter, share a common ancient root, which is this word I can't pronounce, and it means earth or soil, but it's from an extinct 6,000-year-old language called Proto-Indo-European, and that just resonates with me because we all come from Earth and we return to Earth. So
We have a couple
Definition or loose definition?
great question. So I'll try and repeat that back. So Sam asked, is there like a soil where I'd say that's not a soil because it's lacking certain horizons? Like, do I use a strict definition or a loose definition? And that's a really good question, because some people would consider soil to exist on Mars, right, where there seems to be not much living. Yeah, so I guess for me, I think that living component is really important to my definition of soil because it influences so much. And so that upper horizon is really important. I guess it can be super thin in like a desert environment. So I don't want to be prescriptive, but I will say that, seeing what I would call dirt, which is like soil that's been dried and displaced and maybe exists in a laboratory, it's a very different thing, like looking up close at that, than it is looking at soil. So that might be in my definition. And I think when we remove the topsoil, with my earlier work in like soil lead, it gets complicated because like sometimes when there's a contaminant there, you just want to get rid of that soil, put it in landfill so it can't affect humans. But that also removes that extremely biodiverse soil environment. So there's tough choices with soil stewardship for sure. So, yeah.
Like the same grade.
That's such a good question. Okay, the question was, if you compact some soil, how long does it take for it to come back? And I wish I had like a good answer on that. I will say that as soil scientists, we tend to, use these, say things like, oh, it takes like, hundreds of years to form a single centimeter of soil, right? I think a lot of, I don't know, that's commonly said in soil science. But I've seen in like farm fields, I've seen enormous transformations in soil over a matter of a couple years. And I think what's important is how that land is managed. So post-compaction, if you can add some organic matter, or like, if you can maybe give it a rest period from a high traffic kind of area, like I think that's gonna do wonders. And it might, if you cover it in some, compost, a little mulch, like I think it's surprising how quickly it can rebound. And this isn't me as a soil scientist, like able to super weigh in on like time scales. I'm just thinking about my super compacted walkway that I like. I had to like tell myself, I was like, okay, think about the principles, and it rebounded pretty quickly. So I don't know, I hope.
For those studying the arborist exam, would you delve a little bit into how humus and organic matter affect the cation exchange capacity of the soil?
Oh yeah. So they definitely increase it, I would say. But that impact is going to be different in different soil textures. So clays already have a ton of cation exchange capacity, whereas sands don't have much at all. So if you add organic matter to a super sandy soil, that's going to be like increasing the cation exchange capacity by like a factor, whereas in clays you've already got a lot of that. So the influence would vary. Mm-hmm.
Cool. Craig, go ahead.
Yeah.
Quick question here. I know you haven't been around here for very long.
Yeah.
But do you see anything, like what is our primary problem with soils around here?
Oh man.
The limiting factor for, as it relates to trees.
Mm-hmm. I get a little nervous about some of I just think there's so much development happening around here right now, and especially in our Jurassic sediments, which like erode fairly easily. I see a lot of like there's been a lot of sedimented streams and a lot of erosion, and seems like there's a lot of subsoil being exposed, and I'm not sure if I can speak to the tree effect per se, because I'm sure that varies by species, but it does make me nervous to see so much topsoil being removed. And I'm not a construction expert, but I'm pretty sure that they don't prefer to build on topsoil, and so that just makes it harder to establish vegetation. And then like when you have like climate impacts, like from long droughts and stuff, it's easy to see how those subsoil materials lack some of the resilience and some of the like drought, resilience of the topsoil. So I guess that makes me nervous. Mm-hmm.
Jenny, thank you so much.
Yeah, thank you.